Well, thank you for joining us. I'd like to look at a question that requires us to find the value for C. Now, if the tangent to this graph at x equals C passes through the origin. Now, just a little picture here. You don't need the picture, but it's a graph. And at some C value, all right, let's just put that point. That's the point C, and substitute C into there. That's the point C, e to the ax, and so AC. All right, that's the point C, e to the AC. Now it says here the tangent of the graph at that point passes through the origin. So the tangent passes through the origin. At that point. Now the tangent has a gradient at x equals C. You get the dy dx, or get the derivative, and substitute C in. So the derivative of e to the ax is e to the ax times by the product, times by the derivative of ax. Now substitute C, so at x equals C, the gradient will be a e to the ac. Okay, that's the gradient. Now there's 0, 0. There's the point, and we know the gradient. So we can find C by saying that the gradient equals y2 minus y1 over x2 minus x1. So the gradient, which is a e to the ac, equals y2, which is e to the ac, minus y1, which is 0. x2 is c, 0. So therefore, we can just, I'll just make it easy now. I'm just going to take off the minus 0, make it easy because that's the gradient. All right, that's the next step. I just did the next step by rubbing out the minus 0. And I want C. So C, oh look, if I cancel e to the ac and cancel e to the ac, I've got a equals 1 over c. Therefore, c equals 1 over a. So the answer is, in fact, B. Right. A little bit of analytical geometry, derivatives, the gradient rule, and cancelling these two because they're common. We can divide both sides by e to the ac and they cancel. I mean, I could have done this. I could have taken the c across to be multiplied and then taken the e to the ac across to be, that's e to the ac across, and that would have equaled 1. So that's just another way of doing it. All right, I hope this has helped.